It's great to be here again today. This has been a really awesome conference. My name is Chris Munns. Currently, I am a Senior Developer Advocate for Serverless from Amazon Web Services based in our New York City office. Basically, what I do is focus on interfacing with folks like all of you here in the room. So my main focus is to work with AWS's developer customers on understanding what serverless can mean for them, how they think about serverless, how they think about serverless architectures. Now, what's interesting is that I myself, or at least I find this kind of interesting, I myself am not a developer. I actually come from much more of a traditional infrastructure and operations background. I've spent plenty of time in data centers, managing large Linux farms of servers, and doing things like configuration management and all sorts of stuff like that. But a couple years ago, kind of right after AWS launched a product called Lambda, which I'll be talking about today, I really have come to see that this concept of serverless is the future. And so I am very privileged and lucky enough to spend all my time basically focused on this. So why are we here today in this talk? So there's been a number of talks so far this week already on serverless, on what it maybe does mean or maybe doesn't mean. It's definitely a term and a buzzword that's grown to mean a lot of things in the industry. One quick thing that I always like to address is that, yes, we understand that there are servers behind the scenes of serverless, but at the end of the day, one of the key aspects of it is that you don't deal with them at all. And however, though, this is not the point. What we see serverless meaning is actually, I think, kind of the next evolution in how people are thinking about building applications and architectures. And so we've kind of transitioned from mainframes up to server client, up to the web, and even into things like microservices. But what serverless represents is really the whole next life cycle of how I think developers are going to think about building applications. So what does serverless mean? To us here at AWS, it really comes down to kind of 4 guiding principles that we use when we basically will or will not label a product as a serverless product. So obviously, the concept of there being no servers to provision or manage, and this even means things like containers. So a product for us to be serverless, you never think about the operating system, there's no patch management, there's no RDP or SSH, there's nothing like an operating system license that you want to think about. And realistically, you have no concept of those underlying physical servers or virtual servers or containers that might be existing in that platform. It should scale with usage, so as traffic or requests or data points come in, the serverless product or platform should automatically scale to meet that. What that means is that you never have to think about things like capacity planning, so you never have to pay for idle. Realistically, thinking about capacity planning is kind of a business decision on how much idle do we want to pay for in hopes that at some point we have a customer workload that will come and consume some larger percentage of that capacity over time. And then lastly, things like high availability and fault tolerance are built in. And so that's very key today when developers are thinking about how they structure their architectures, where in the physical world, or even the virtual machine world, or even the container world, these are things that you still are typically spending a considerable amount of time thinking about and architecting for. So kind of 4 overall, again, guiding principles in terms of what we feel serverless means. And I think it aligns pretty well with how most of the industry is talking about it today. Now, where serverless kind of started for us here at AWS is around this product, symbols right kind of in the middle here, Lambda. And so Lambda is a compute product that we have here at AWS today. Many of you, I think, maybe are familiar with it. But if not, I'm going to spend some time talking a little bit further about it. And when we talk about Lambda, we talk about it in the sense of being in the middle of what we'd call a serverless architecture. And so with Lambda, you have a concept of an event source, some sort of triggering mechanism that is going to cause a Lambda function to be invoked. And then that Lambda function can do basically whatever it is that you want it to do. Talk to other databases, other APIs, queues, caches, data stores, what have you, based on what it is that your application needs to do. And so a serverless architecture, again, is pretty much we'll always have some sort of event source. We'll always have Lambda at some point doing compute, and then may or may not have other services that you might be talking to. So you could potentially have all of your business logic exist just in Lambda. And when it comes to kind of the architecture use cases that we see for serverless, it's actually a number of things. So web applications, basically the ability to power things like static websites or things like single-page apps, that's very common. And something that we see growing, especially when we see people moving more towards the single web page applications with things like React and other JavaScript frameworks that behave similarly. Backends, so things like microservices, which has been a big topic this week here at the conference. See people building that using Lambda and serverless. Data processing, so real-time stream analytics, ingest of things like user clicks, data points from IoT-related workloads, all sorts of things like log analysis and other kind of things where you'd get massive quantities of data. And typically, organizations would do things like batch process them in some sort of semi-regular interval. Well, people want that information processed almost immediately these days. And so we could potentially talk about how real-time needs to be. But in the case of streaming workloads, it usually means very rapid ingest, typically in the order of seconds. And this is actually kind of today, basically dollar for dollar, one of the biggest use cases that we see for Lambda and serverless today. Things like chatbots, so how you interface with your customers or maybe internally inside your organization, also rapidly changing. I've seen things like internal enterprise chatbots that they use for kind of disseminating information that normally would have existed maybe in a wiki or a SharePoint somewhere. But then we also see people putting them publicly on their websites to act as kind of like sales type of enablement bots or even customer support bots, and that continues to grow in use. Alexa, something that I talked about yesterday actually, I attempted to build an Alexa skill on stage live. Were any of you in that talk at all yesterday? A couple of you. So it was kind of a race against the clock, and we got to see some interesting aspects about Alexa and the Alexa voice service and its understanding of my New York drawl, as it were. So that was kind of an interesting session. But Alexa really growing in terms of power and capability. There's something like over 17,000 Alexa skills today. And you can think of an Alexa skill as kind of a micro voice-controlled application that lives inside of a device that's powered by Alexa. So you could say things like, Alexa, turn my lights on, or turn my lights off, or tell me the weather, or tell me my current bank account number, or get me a pizza. There's all sorts of things that you can do with Alexa. And then lastly, IT automation, which is actually where I think a lot of people start with Lambda, is using it inside of AWS to do things like glue together various services and components inside of your infrastructure. And I should say actually using this in other places. I actually have one customer that uses Lambda as part of a framework for managing physical network gear inside of their data center. So they built a management API in front of Juniper devices actually, and have been successful in building this kind of really cool interface in front of physical hardware and physical data centers. So again, number of really kind of common use cases here. Today I'm going to focus a little bit more on the web application aspect, but happy to potentially talk about the rest of these outside of this. So for those of you that are new, where do you start? So this is really a whole new world again in terms of how you think about applications. And for a number of folks that I've talked to, it can be a little daunting to go from the model of I have a server and typically that contains everything about my application or even a multi-tier architecture to this thing where servers no longer exist. And so kind of the foundational construct that you've used from a development paradigm is no longer around. So my first tip is actually to start with a framework. So there are a number of frameworks that exist out there. And what these are going to do is kind of greatly simplify what is involved in you building a serverless application. There's actually many more than the ones that are up here. These are some of the most popular ones that I've seen. And I know the creator of Claudia.js spoke yesterday. And really what kind of differentiates some of these is the languages that they're supporting or capabilities like multi-cloud capabilities or other types of aspects or nuances around like the languages that they support. So Claudia, just an example here, is a JavaScript framework, hence the JS in its name. And with Claudia, they have a really easy model for building API backends. So you can see here in what is roughly, minus the fact that it got kind of squished on the slide, roughly about 5 lines of code. With these 5 lines of code and the command that's right here at the bottom of the slide, I get a Lambda function and an API gateway and all of it integrated together. And effectively, I have an API backend. And obviously, hello world is not a lot of complicated business logic. But again, this is the scaffolding needed for a very basic API that could grow to become very powerful over time. Chalice is actually a framework that came out of us here at AWS. What's interesting is this didn't come from any of the serverless product teams. It actually came from our SDK team. They had an itch to scratch around building a framework to help them out, and they ended up building this product, Chalice, kind of on the side. And so it's an open source product that you can go and contribute to and read about. And so this is Python-based. Similar kind of thing to Claudia, about 5 lines, and I get an API. right? So this is compute capability, API gateway acting as the front end. And we can actually do quite a lot of really kind of advanced things with this, much like most of the other frameworks. So let me just dive just a little bit deeper briefly here into Chalice. And while I won't expect you to read everything that's on this slide, it's roughly about 30-ish or so lines of code. What is inside of this, though, is actually 4 API endpoints in terms of what we would call an application route, so the type of thing that ends at the kind of the first part of a URI on the URL for an API gateway. And then as part of that, there's things like built-in error handling and various HTTP method support. There's also integrated support for different authentication and authorization capabilities. And again, I'm getting all of this in about 30 lines of code. So when you're starting out new in this space, I definitely recommend you take a look at a framework and try to work off of that. Now let's say that you had an existing application, or maybe you have a language of choice that there isn't a framework that you like in. So what we have at AWS now is a tool of ours called SAM. You'll also notice SAM, which is our little mascot for serverless. Over in the expo hall, we've got a lot of stickers for SAM. We're really trying to put SAM into all sorts of things. But what SAM is actually a template-driven model for defining serverless applications to really kind of simplify what it takes to build and deploy them. And it's completely unopinionated from the language standpoint. It basically is just used as an infrastructure management tool. So an example of a SAM template here, what we've got is about roughly 20 or so lines of code. And what this actually represents is the very top we have some headers that kind of tell the service what this template's going to do. And then we have 2 resources. The first is a serverless function. The second is what's called a simple table. Now, a simple table I'll cover real quick. This is actually going to create for you a DynamoDB table. And all you need is essentially this one line of code and then a name for it. And a couple months ago, we launched auto-scaling for DynamoDB, so we do consider it now a serverless NoSQL database product. But up above here, this serverless function type, what you see is kind of a number of things that would be used to categorize a Lambda function. So where my code lives, where the handler for that code lives, and I'll talk about this here in a moment, the language that I'm using, permissions that I want to give my Lambda function, and then down below here, there's a concept of an event. And so I have an event that is of type API, and then you see some API properties that are defined below. And so what will come from this is a Lambda function, an API gateway, a DynamoDB table, and then all of the related kind of glue components to combine all of these. Now, if you were to do this in the console, this would be quite a number of clicks. So, try to think about avoiding those and instead use, again, one of these frameworks. Just to give kind of a slightly better visualization, this is from an example that I'll show here in just a little while. What I have is from roughly lines 9 through 25, all of kind of the meat of this SAM template that I have. And what gets created from it is roughly the 6 resources that you see here. So again, really easy to get started from this when you're just trying to figure out what the serverless space looks like. And a lot of power to frameworks as well as things like SAM. And then just a couple of, about a month and a half or so ago, we actually launched a tool for local testing of serverless applications. So you can actually now do local kind of debug and test of both API workloads and then things that would connect to a Lambda function via, say, like a streaming invocation or some sort of other event. And so this, again, kind of simplifies the developer lifecycle, which is pretty key when you're just starting out. So let's get hands-on with some of this. Let me show you actually an example of a Lambda function, and I'm actually going to show you some SAM and SAM local as well. Cool. So the example that I'm going to pull from is actually something that you could go and find yourself and play with, and if your AWS account still is covered by the free tier, you could play with this with absolutely no cost. If it isn't the free tier, you could basically run this demo for pennies for probably some number of weeks of time. And it's actually pretty straightforward. What it does is it has you launch a website, and I'll show you this here in motion, where our friend Sam kind of bounces around the screen. And it includes all of this front-end code in S3, and then you have an API gateway and a Lambda function that glues it all together. So this is my example here of the SAM farm. So as we see, I have my wonderful friend Sam here bouncing around. There's some collision detection so that they don't overlap. And essentially what we do is we have a single Lambda function. And all that this Lambda function really does is spit back out to me a SAM count. So a SAM count is the combination of, make this just a little bigger. combination of a variable called var SAM count, and then about 2 lines down there is a multiplier, which I can either pull in from an environment variable or have it statically set. And then basically it gives me the total count of SAMs. And so the API is super, super, super basic. So I have this running here locally on my, my laptop. I've also now gone and actually fired up, just right before we started here, the SAM local. And actually, let me show you real quick here. So this is the SAM template. That's the whole thing. This is the SAM template for this demo. So again, roughly from lines 9 through 26 is kind of the whole meat of what I'm going to do. So this is a Node.js 4.3 runtime. Index.handler is my handler. The code URI, which has a dot and a slash, I'll talk about here a little bit later. We see some environment variables, and then we see the event mapping down below. So when I actually have this template here, and I'm running against SAM local, what I have done is just basically gone and executed it. So SAM local start API and referenced the SAM template. And then what that does is take my code, bundle it into a Docker container running locally on my laptop, such that I can go to the interface that it gives me here on localhost and be able to call my API. Now, I just have a single API endpoint, but if I had multiples, it would show me kind of the full mapping for all of them. So, the basic. Oops. Go here. Great. So this is the number returned by my API right now, and this is a factor of that currently in here. I have the number 10 and a multiplier of 1. Then I can actually go back to the SAM local window here, and what I get is the same output that I would get from this Lambda function if it was running in the Lambda service. So if you're familiar with Lambda at all, you'll see here the same kind of output and error lines, or not error lines in this case, but the output lines from this function are put out right here. Down below, I have the duration that it took, the build's duration, and the amount of memory used. So pretty cool, really easy, kind of straightforward thing for me to do local testing with. And there's a lot more capabilities of this. So one quick thing that I'll show, so let's say that I goof up here and I turn SAM count into cat. Now cat is not a valid number, as most of you are probably well aware. So if I go and refresh this and I get an error message. More importantly than that, I could see from my local test tool that it told me that, guess what, cat is not defined, and so that is a problem. And tells you where that line is that's broken, and so it makes it really easy for me to go back in and fix that. So again, in terms of starting out, you definitely want to think about a framework. If you really are averse to a framework, definitely use a tool like SAM and SAM local, because it's going to make your development lifecycle just that much more rapid. So let's get just a little bit deeper into Lambda for those of you who aren't that familiar with it, and kind of talk a little bit more about what happens behind the scenes with Lambda and what you can do to kind of play with and configure Lambda. So with Lambda, I had mentioned that basically a serverless architecture has some sort of invocation model or method, then you have your function, whatever that function does. Today there's basically 3 different types of invocation models that exist for Lambda. So we have synchronous, effectively a push. We have asynchronous, which is more of kind of an event. And then we have stream-based. And so the use cases across them really kind of vary across what integration product or method for integration you want to put. So we see here an example of an API gateway where I'm going to make an API call, and I'm going to expect that my API call is immediately returned. And so that's kind of a very traditional kind of synchronous push model for using something like an API endpoint and something like Lambda. There are also things like the asynchronous event-driven. So this is stuff like let's say you have customer data that comes to you, whether it be an image file, an audio or video file, or maybe even things like a document. And you want to go through and do text processing on that. Maybe you want to generate metadata from that. Maybe you want to take an image and resize it or convert it into a different format. And so this is a model where you're typically not looking for a response right away, but you want to do something out of band. And so that's where the asynchronous event-driven models fit in really well. And again, that's something that's kind of the bread and butter of what people use Lambda for these days. Really kind of straightforward use case, but really powerful and easily scales. And then lastly, stream-based. This is where you would basically connect it up with something like DynamoDB or Kinesis today, where as requests come in, so in the case of DynamoDB, people are writing, updating, or deleting records in your database. it will actually stream those changes back and cause a Lambda invocation. Or if you're ingesting data with something like Kinesis, which if you're not familiar with it, it's kind of a mass scale ingest service, so very similar to a Kafka, a number of other things. But basically, you can just kind of toss records into Kinesis, and eventually it could be processed by a Lambda function. And again, this is really useful for things like IoT workloads and clickstream analysis and log analysis and things like that. So 3 different kind of main execution or invocation models that we have. And then what exists today is a little over 20 or so services that are integrated today from the AWS side of things. So just kind of a brief example of what is possible. Those things like data stores, things like development management tools. This is effectively the infrastructure glue use case that I was talking about before. Things like endpoints, so API gateway, AWS's IoT platform, step functions, which we'll talk about here briefly. Things like Alexa again, so Alexa can directly invoke a Lambda function as part of you conversing with it. And then lastly, we have things like message services, whether it actually be things like SES or SNS, or also the ability to do cron jobs. As someone who spent a lot of time managing servers, managing cron jobs is always such a pain in the ass. And so you can have a completely kind of managed, abstracted away for you system for doing cron jobs, and it's actually really, really pretty cool. So just talking a little bit deeper about 2 of the products that are like really tightly aligned with Lambda. So API Gateway is an API gateway. We weren't the first people to come up with this product as a concept, but what Amazon's API Gateway does is give you things like caching both in the gateway and at the edge, the ability to get logs and metrics from it. You can actually put API Gateway in front of not only Lambda, but pretty much any sort of HTTP or HTTPS endpoint that you have. So we have customers that will put API Gateway in front of things like on-prem resources, or obviously things like EC2. And API Gateway comes with a lot of kind of really cool capabilities for you. So obviously it's going to give you the ability to build an API front end, but it also has built into it things like DDoS protection, throttling, authentication and authorization mechanisms, the ability to do things like metering, or to do usage tiers, which are all really awesome things if you're ever building a consumed API by, say, external developers. It's also the kind of thing that there's really no reason for you to write your own today. So there exist kind of many different API gateway products on the market. I would say if you're building something that is an API, you should always have some sort of API gateway that you're using. And so with Amazon's API gateway, we consider it a serverless product. There's no servers to manage. There's no scale to think about. And again, it can alleviate things like authentication and authorization concerns, which developers spend typically a lot of time on. And then next, another kind of product in the suite is AWS Step Functions. So one common thing when you have Lambda functions is, they're these small little kind of bite-sized amounts of compute. Well, rarely do we ever just need just a small little bite-sized amount of compute. And so we often have to do things like chain them together or have them invoked in reaction to each other. Then you want to handle things like retries and failures, and there's all sorts of logic that you want to put around there. Now, you can put that logic directly into your code, but you end up running into issues with things like the fact that a Lambda function can only run for up to 5 minutes today. So if you have a Lambda function calling another Lambda function calling another Lambda function, if that first one times out, you lose basically the chain of everything below it. And so Step Functions allows you to basically abstract all of that workflow knowledge into the service itself and can do things like, as you see above here, decision trees, ability to capture failures, ability to do parallel tasks, to do certain sequential tasks based on that. It could actually also handle things like custom error logic. And so if you have kind of a multi-step workflow inside of an application, this also kind of, again, will alleviate the ability or the need for you to have to write the logic that exists between there. So definitely take a look at Step Functions, again, if you have those types of workloads. So let's get a little bit back to Lambda. So with Lambda, we've really, I think, made it as almost as simple as possible as it can be from a compute product to think about how you scale it. Realistically, there's kind of a single knob that you could turn with Lambda, and it's the amount of memory that you want your function to be able to potentially ever consume. What comes with that is a proportional amount of CPU and networking resources. So you're never going to say, I want a Lambda function that has a 2.3 gigahertz Xeon processor. It's not the kind of thing that you're going to care about. What you're going to say is, I want a Lambda function that has access to 512 megabytes of RAM, and then we're again going to align proportionally some percentage of a CPU core to that. And so if you do have a workload that is more compute intensive, you're going to crank up the memory, because typically we find that those are very well aligned. And so this is, again, kind of the only knob that you get. But there is one caveat about this. It's not always better for you to crank that knob all the way up. And so what we have here is an example of calculating 1,000 times all of the prime numbers less than 1,000,000. And what you can see here on the chart is, so today Lambda supports up to 1.5 gigs of memory. This actually just compares from 128 megs to just 1 gig. If you look at the timing, obviously the more amount of memory that we have, the faster that our function gets processed. But from a cost perspective, it's not necessarily the most cost efficient is always the fastest. And so you can see here that roughly, if we were to compare cost, the first, or 128 megs cost just about almost the same as a gig. But if we were really looking for maybe an optimal time versus cost model, the 512 megabytes might have actually been a better fit. And so you want to think about kind of in your workload, do I care about speed or do I care about cost? So in things like API calls, you probably care a little bit more about speed. But in things like batch processing of doing things like stream analysis or event sourcing, you might actually care a little bit more about cost. And so this knob gives you quite a lot of power, but there is a little bit of thinking that you want to do as part of that. Another thing that you want to think about is Lambda runtimes. So today we support 4 different languages inside of Lambda, Node.js, Python, Java, and C#. And there's a couple different aspects to why you would pick one of those or when and where. But things that you want to also think about is always kind of separating the business logic from the function signature, as we'll call it. Things like dependencies, you want to be really smart about what dependencies that you include. And then in terms of the overall runtimes, the interpreted languages, so Node.js and Python, are significantly faster to start than Java and C#. But that's just during the start time. We still find that often for a number of customers that the compiled languages might be much faster at things like mathematical calculations or even things like transformation of an image, for example. There are some tools in Java that make that a lot faster than in Python or Node.js. So when it comes to thinking about how you separate, so we've got to go through these 3 areas here. So separating your business logic from effectively the signature. So what we see here is that I've got kind of a mocked up function here called app to do. And then what I have is my handler. So the handler is what Lambda is going to look to invoke when you have a request that comes in. This is basically the entry point into your code's execution. And we'll talk a little bit here in a moment about something called effectively container reuse. But when a container reuse happens, it's going to execute what logic exists inside of this Lambda handler. And you actually want to keep your Lambda handler kind of as clean as possible and think about taking any sort of extra application functionality and either moving it elsewhere in this file or potentially think about modularizing that out into, say, like a package that you include. And we'll talk a little bit about best practices for that as well in a bit. So when it comes to container reuse, something that I'll kind of explain real quick. So no, Lambda does not run on top of Docker. Doesn't run on anything that looks exactly like Docker. We use container in kind of the lowest sense to refer to effectively something that lives inside of the kernel space of the host that is running Lambda for you. So we'll talk here about the lifecycle, but basically what happens is when you have a Lambda invocation, we fire up what's considered a container on a host that we manage. We pull your code into it, we execute your code, and then your code finishes executing. Now, you only pay for the duration of your code execution based on the hundreds of milliseconds of time. But what we will do for performance reasons is keep that host around. And so from that point, you have what's called a warm start. And I'll visualize this here in a second. So there are things that you could do inside of your function to actually speed up the warm started execution, such as moving certain logic or defining things like certain variables into the global scope. This can actually speed up your function quite a bit, depending on what it is that you need to do. Let's say, for example, that you needed to reach out to a key value store to pull in a certificate. That's the kind of thing you would want to do outside of the handler in the kind of early lines of your code before your handler is executed so that you don't have to do that every time, because typically that type of thing is not going to change that often. So let's look at kind of a better way to visualize this. So when a Lambda function is executed, again, what we do is we have to download your code, start a new container for it, bootstrap the runtime. So this could basically go through anything like an include or require inside of your code, and then start your code and execute it. And so when we talk about where this kind of lies in terms of what you think about optimizing versus what we think about optimizing, so a full cold start is where we don't have a host that has your code on it. Or for some reason, due to scale, we have to create a new host and pull your code onto it. And then on your side, a partial cold start is we have a host, it has your code, but it doesn't have a container that has your code in it. And then warm start is we have a host, it has a container that has your code, and an invocation has come in, and so we're going to execute it right then. And so again, what you really want to be thinking about is from the bootstrap of your runtime, and this is where things like interpreted languages versus non-interpreted languages becomes important, as well as what it is that exists inside of your handler that is going to be key to the performance of your function. Now, this is a bit different than if you're thinking about in a traditional application environment where you have kind of a, all of your, like a warm application server. This is a bit different of a model because effectively we're invoking that every time behind the scenes for you. And so what ends up, one other thing that we have is if you run inside of a VPC, this is another thing that customers have found. What you actually also have to deal with is the fact that we have to put a elastic network interface on your function in your VPC. So one thing that we'll always recommend is don't use VPC unless you have to. So unless you have to talk to a resource inside of your VPC, because it does add to the it does add to the cold start time for your function. So important to think about this from the perspective of how you think about what you include inside of your event handler, how you think about what you include in your code. This is also why it's really important to not include extra modules in your code. This could be something that's very common today in both Python and Node.js is, hey, we're going to include all these modules that do all this cool stuff, but maybe you only need a small bit of functionality. You're actually better kind of going with building that functionality yourself or stripping it out of that third-party package. So I want to demo some of the ways that this is kind of key. So if I go over to the Lambda console here, let's see if it's going to still be warmed for me. Okay. So this is actually the Lambda function that was behind the API gateway endpoint that this interface here is built upon. And what I have here is the ability to test this Lambda function. So let's see how fast it went. Okay, so in this case, it was executed in 14 milliseconds. So let me find one that is going to be cold that I can really easily execute. Let's see if this will work. Yeah, this should work. So I'm just going to create a very basic test. Hoping that this function still works. Cool. So this is a function, actually it ran, oh, internal error, that's why. What I'm hoping to highlight here is a cold function that I can use to show, let's see if this one will do it. Okay, not a great example either because it was too quick. Anyway, what you'll typically see when you're building and testing a function, if it is a cold function that has not been executed, the initial time that you go and execute, or the first time you go and execute that function, the duration is going to be much longer because we have to go through that full cold start of getting a container, pulling down your code, executing your code, and returning the result. However, what you'll see is if you do these tests in semi-rapid succession, you'll find that duration stays effectively very, very small. And so this is why sometimes people think that the first time that they run Lambda that it is slow. And what you're seeing there is that first initial penalty of the cold start that causes you to think that that's what's happening. But realistically, what we find for almost all of our customers that are running in production, cold starts are not something that they have to really worry about. Typically, most applications are going to be accessed somewhat frequently, so periodically every couple of minutes. And so things like cold starts really kind of trail out to the very far end of, say, like your TP99 in terms of performance pain points. My apologies for not having my example working to show you this. Of course, right before I came in, I was doing the SAM function one, and but it's because I hadn't tested it from the web interface. So now it's unfortunately a warm function, so it's not a good example of what happens when a function is called. Yeah, it's going to return really quickly. Okay. Moving on. Cool. So again, cold starts, they can look bad in development, but you have to understand that an application under load is not going to see that same kind of performance problem. We actually have wonderful stats and charts and data points that show this for our customers, and we've had customers under load show it as well. More memory is not always more expensive, but it's not always the best thing to do. So you do want to kind of tweak your function and tune it for how much time it's going to run for based on how much memory and CPU you might need. And remember, we give you just a single knob that's aligned with memory, but you do get more CPU with that. And so that's kind of one other kind of key thing when people talk about performance. And then lastly, you necessarily don't want to think too much about over-optimizing your code. So I've had customers come to me and say, hey, we're doing this in Python, should we be doing it in Java, or vice versa? You do want to really think about benchmarking your functions to understand how much time you're spending during that kind of cold start or initial bootstrap versus when it is warm. So again, if you're testing this in something like the console, it's going to look much slower with something like Java than Python, but that doesn't mean that under load your application is going to perform equally compared to you doing kind of one-off click tests in the console. So let's move on and talk about a couple of other things here. So talk about how you really can't move fast if you're not measuring what's going on. So Lambda has built into it a number of capabilities. So it has built into it CloudWatch metrics, so the ability for you to understand things like invocation count, invocation duration, invocation errors, if you're being throttled by the back end. So today the concurrency limit that we set is 1,000 concurrent requests. Note that this does not mean 1,000 concurrent requests per second. It means concurrent within basically a time frame smaller than that. So because we build functions in the hundreds of milliseconds, basically you're looking at a concurrency of just completely at execution time. This could be something that can throw people off because it means that you can actually invoke more than 1,000 functions in a second, but you couldn't invoke more than 1,000 functions in, say, more than a millisecond. For API Gateway, same kind of thing. So we capture a whole lot of data for you. You definitely want to pay attention to those things and look at those graphs and understand how to use them for troubleshooting and understanding what's going on for performance-wise. We also, in terms of logging, capture a whole lot of logging for you. So with CloudWatch Logs, which is another AWS product, with API Gateway and with Lambda, we capture a number of things by default. With Lambda, you can basically put information into your log just by outputting it. So just kind of doing a standard kind of console.log or whatever the equivalent might be in the language that you're using, that's all going to get captured and made available to you inside of CloudWatch. CloudWatch has abilities for things what are called log pivots. So this is actually the ability for you to generate metrics based on logs. So this is one quick way actually to create data points from your function and then use that to generate kind of like a visual graph. And then really, so people will, I think, somewhat rightfully complain about the CloudWatch Logs interface. It's not the be-all, end-all of log processing interfaces. But really what we encourage you to do is think about taking that data, exporting it out to a tool that you like. So there's tools like Splunk and Loggly and the Elk Stack and a number of other things that are really deeply powerful log viewing tools. You're going to want to pull that data into one of those most likely. Something that we had integrated with Lambda a little earlier this year is a product called X-Ray. So X-Ray is not an application performance tool. So it is not meant to replace a Datadog or a New Relic or an AppDynamics. In fact, those products are actually mostly building integration with X-Ray. What X-Ray provides for you is profiling and the ability to troubleshoot your functions. And so it captures what are called traces, which then get built into a service map and can kind of give you a view of when you have a function that has been called by an API that talks to many other services, effectively what the latencies are that were involved on that, what the successes are, or potentially failures or issues, and it makes it really easy for you to debug kind of distributed systems, which is a challenge otherwise. So here's kind of an example of using X-Ray. There's really kind of just two lines that I've had to change in this code. The first one is to include the SDK, and then the next is to basically create my AWS SDK client with the xray.capture AWS put in front of it. That's basically all that I have to do to tool my code to be able to gather information from X-Ray. And I can actually do much more. I can actually get like into functions and create my own capture. but this is going to give you kind of the basic functionality. So this is code wrapped around calling something in S3. So I have a bucket, I have a key, and I have a body that I'm going to put into this S3 object. What I get from this is a service graph. So I see that X-ray, or I see that Lambda has an invocation. That's the first thing that you see, AWS Lambda. Then the Lambda function itself executing, and then it putting its data into S3. Now this is a really, really, really simplistic example. Typically you'd have a Lambda function that maybe is talking to S3 and a database and some sort of other service, and it's going to map out that full map for you. The other thing that it does is give you kind of a waterfall view into your code, or into your application flow. So we actually see all the way on the far end here, response codes. If it was an HTTP call, we see the duration, and then you can kind of see a visualization of the duration. So this is another thing that's really kind of key in understanding the performance of a serverless application. Cool. So that's kind of metrics logging and profiling. So next, I'm going to just talk about build and test of your application. In this case, actually build and deploy your application. A couple products here I'll talk about really quickly that can help you with this. So code build is a managed CI service. This is useful for compiling code, for including code dependencies, for testing your code at the code level. So doing things like unit tests, linting, syntax checkers, that's pretty much exactly what code build exists for. And so this is a managed service for you so that you don't have to run, say, a Jenkins or a TeamCity or something like that yourself. So it has a command file basically that you put in your code base called a buildspec file, or buildspec.yml file in this case. And so what we see here is just kind of like basic sections to it. The first are environment variables. Then we have phases, of which there are 4 of today. And so you can see that this would be for a Node.js Lambda function. So I'm doing an npm install. I'm going to run ESLint to make sure that my code is clean. I could be doing npm test for unit tests. And then I'm going to actually package it up. So the AWS CloudFormation package command is part of what SAM needs in order to build and deploy your application. And then I can tell it exactly what I want to put into that application that I care about. Typically, you're going to plug something like code build into some sort of a pipelining system, so some sort of a continuous delivery system. And so we have a product called Code Pipeline that does exactly that. This allows you to kind of model out from code to build, to test, to deploy across many different stages potentially. So typically, a developer's pipeline will look something, well, this is just kind of a snippet of part of one, but you commit your code to your code repository. Then that's going to be packaged and tested in code build. And then you're going to use something like CloudFormation to deploy it. So if you're using SAM, you use CloudFormation. Or if you were using one of the other framework tools, you could basically actually have a Lambda function that calls one of those. So it's kind of fun. You could use Lambda to deploy your Lambda. So the most minimalist kind of developer's pipeline that you would see looks something like this. So I have my application source, then I have my build stage, and then I have a stage down below here which uses CloudFormation to basically deploy my function, and then I could do some testing against it. So depending on what it is that I'm using, I could be using something like SAM local actually to invoke requests to a Lambda function. I could use the Lambda API to test something, or I could use a third-party tool to, say, test an API. And creating this is actually really, really easy with something called CodeStar. So CodeStar is kind of an interface that sits on top of a lot of these products. It has the ability for you to create what we call projects that are based around various different technologies. And so this is probably the easiest way to go and create what you see here in this slide in terms of this deployment pipeline. So if you're starting out with serverless and you're starting out with Lambda, this is definitely a good place to start with looking at all of that. So I want to kind of wrap up here with some best practices. I'm running a little long on time, my apologies. So common things that I see people creating what I call Lambda monoliths. This is the idea that you're going to put all of your functionality for, say, an API or for some sort of a service inside of a single function. This is not a good thing to do typically. So again, I had mentioned the more code that lives inside of your deployable artifact, kind of effectively the slower the Lambda is going to be for a cold start, also potentially complicates a warm start, but it also doesn't help you in thinking about how you should build Lambda functions. And so realistically, you want to think about is Lambda as kind of what I like to call nano services, so even smaller than a microservice. So you could think of kind of every HTTP endpoint and call that we would make as its own Lambda function. So every HTTP method correlating to its own Lambda function. And again, this is where tools like SAM and the various different frameworks that exist make this really easy to do, but it's something that people are very much not familiar with thinking about, like really decomposing their application as small as possible. So unless your code, basically, your function handlers share an invocation source, you want to split them up into their own independent Lambda functions or binaries if you're using, say, Java or C#. And again, that's kind of a best practice that you really want to follow. Another thing that you might want to think about is bundling your code into your own packaging. So people will say, okay, well, I'm going to decompose my Lambda monolith into individual Lambdas, but I have a lot of code duplication. You know, any place that you see code duplication, think about using kind of a language-based module, an NPM, a pip package, a Maven package, etc. Unless your Lambda functions share the same type of event type, so if you have Lambda functions that some are being invoked by an API gateway, some are being invoked by, say, a Kinesis stream, those should be completely separate projects, completely separate SAM templates, completely separate code bases. So again, if you're sharing a handler, you still want to think about splitting them into files in the same repository. If you're using completely different handlers, then completely different repositories, they're completely different applications. Again, lean on code reuse via packaging modules. And then from a testing perspective, for SAM templates at least, always validate them locally before you upload them. So when you upload a SAM template to CloudFormation, it does take time for it to process it, and it's actually a very, it's perceived as slow, but it's doing a lot behind the scenes to update your resources in a very controlled methodology. And so sometimes if you fat finger something inside of a template file, you can find that it takes a couple of minutes before you get the results on that. And then lastly, inside your CI and CD process, always validate them as part of that. So again, going back to the build spec that I had, I would be inspecting my files inside of there. Lambda and API Gateway, which we'll talk about here in a second, support something called environment variables. Pretty straightforward. The ability for you to have essentially a key value pair that allows you to add effectively dynamicness to your function execution and to what you're trying to do. So like 2 minutes, 3 minutes, right? Ish. Okay. So this is really useful for, again, adding dynamicness to your environment. So we could see here an example of a SAM template where I'm capturing 2 parameters from the user. So I have something called special feature 1, another one called my environment, passing them into the references for my actual code, and then your Lambda function can consume these. So maybe you have some capability that you only want to test in staging or dev, versus things that you have in prod, or you want to pass in keys in one place and not another. This kind of gives you that capability built in. Another option that you have is something called parameter store. So parameter store is kind of a centralized place for keeping data like key value pairs. So API keys, database credentials, configuration, environment variables. What you can see here is actually a snippet of Lambda code where I'm calling out to the parameter store service. I'm pulling these in and then executing upon them. And so what's great about this is there's concepts of hierarchies, there's IAM permissioning that goes around it. So let's say that you have more of kind of a controlled enterprise environment. You can give developers access to the certain parameter stored data for developers, and then you can control for production, but you can have the code base consuming them exactly the same. So one code base that can run in any environment without any sort of change. And so this kind of aligns back to, again, some of the best practices of, always use parameters and as much as you can environment variables such that you can create a single SAM template that can be used in multiple places. This actually extends up to the other managed frameworks as well. You want to think about reuse of those as much as possible so that dev always looks like staging, staging always looks like prod, and therefore you have kind of the different environments that you want to have. Skip ahead here just a little bit. So all my slides will be posted, and so we'll be able to catch up. So just kind of wrapping up here, because I know I'm out of time. So sounds easy, right? There's a lot of different aspects here, a lot of different things that we talked about. Again, there's the serverless space is really exciting. I find that it's really changing the way that companies think about building their applications. We kind of walked through a number of different aspects today of where you start, where you kind of grow through in terms of monitoring and logging, how you think about building out kind of more of a professional development workflow with building and testing tools. Again, start with frameworks and kind of look at some of the things like CodeStar to help ease your path through this. Serverless application, once again, basically things built around Lambda. So we really see things like functions as a service as the future of application development, especially in an event-driven model. There's lots of different things that you could think of that make an application event-driven. In closing down, pretty much everything I talked about today can be found on this website, so aws.amazon.com/serverless. All of the tools that I talked about, including the third-party frameworks, can be found on a page linked off of this at aws.amazon.com/serverless/developer tools. Again, with that, my name is Chris Munns. I'm a developer advocate for serverless at AWS. You could find me at Chris Munns on Twitter, Munns on Amazon.com. Always happy to answer questions about whatever I can. And in terms of today, I'll take questions outside so the next speaker can set up. But really appreciate you coming to this session. Hopefully you learned a little bit more about Lambda and serverless. And thanks again.